Can anybody please confirm whether I'm audible and the screen visible to you? Okay. Thank you so much. Okay. So, 1 minute, please. Okay. So this is the 10th live session of Quantum Topology NPTEL course. Uh, okay. Before starting further, let me know. Do you have any question or any doubt from previous sessions? Before starting further, let me know. Do you have any question or any doubt from previous sessions? Okay. It seems there's no. Uh, okay, Sumis, it will be better if okay. So I must mention one thing. If you have any question in between the session, you please unmute yourself and speak up. Okay, because while the session is going, I might not able to look into the chat box. Okay. Okay. So since you don't have any question, and Mustafa, do you have any question? Okay. So it seems that there is no question for today. Okay. So from today onwards, we shall start with what. Okay. From today onwards, we shall start by solving the previous assignments whose answer has already been released. Okay. So, okay, so let's start. So, 1 minute, please. Okay, so let's start with the first question. So, the first question is as follows. Okay, I must mention one thing that if you have any question or doubt into the session, please unmute yourself and stop me and ask the question. Okay, because this session is mainly for the problem solving sessions. Okay, not for theoretical session. Okay, so let's start with the first question today. 1 minute. Oh, so this is two. Yeah, I think that's better. Okay, so okay. Okay, the first question is as follows. So suppose let x equal to R2. Okay, and in R2 we are defining an equivalence relation as follows. 2 points x1 y1 will be related to x2 y2 if x1 plus y1 squared is equal to x2 plus y2 squared. Okay, x2 plus y2 squared. So, and let x star be the corresponding quotient space. Now, the question is x star, that quotient space, is homeomorphic to a familiar space. What is it? So, what is the question? The question is that, yeah, okay. So, what is the question? The question is that, suppose x equal to R2 and there is some equivalence relation. X1, Y1 is related to X2, Y2 if this relation holds. Now the question is X star is the corresponding Cauchy space, and now we find what X star is a homeomorphic family space. What is it? Okay, please think about it and let me know your answer. Okay. So before thinking, let me put a few observations regarding this question. So this is R2. Okay, at so this relation gives what? This x1 square plus y1 square equal to x2 square plus y2 is what? Means 2 points are related if and only if they lies they lies on the following type of parameters. Correct. So here on this parabola, any 2 point, these are equivalent points. All points are equivalent in all this kind of parabolas. Okay. So now try to think or visualize what will be the corresponding quotient space. Okay. Think about it and let me know. Fine. Okay. Anybody is able to figure out any idea or any process, but at least first you try to visualize or try to guess what will be the quotient space. Then after guessing, might be a separate method to prove that quotient space is nothing but homomorphic to this or this. But first try to guess what will be the quotient space. That is the first important thing in topology. So please try. Okay. So since uh, okay, it's quite tricky also. So okay, so let me give some argument for this. Okay, at least first let me explain how you can guess. That is the most important thing. Okay, so the process is as follows. One. So the process is as follows. Okay. So so this is a real line. Okay. And what we are saying, we are saying that any 2 points over this kind of parabolas are equivalent. All are equivalent. Okay. So, so in these parabolas, if we choose this single point in the quotient space, this single point contains is this single point's equivalence class is the equivalent. I mean, this single point equivalence class contains all of these points, right? This single points equivalence class contains all of these points of the rest of the parabola. Similarly, here for the next parabola, this intersection point, this equivalence class contains all of the points for the rest of the parabola. Similarly, for the other parabola also, that intersection point contains all the points from the rest of the parabola. So the possible case x upper star should be what? Should be. So what's so x plus y squared equal to c. So this implies what? Y squared equal to what? Y squared equal to c minus x. Okay, correct. So this tells that at least the diagram tells that this x star should be so there should be all these points here and all these points in the right center. So it should be r x equal to real line with usual topology. Okay. It should be the case. Now we need to prove that our case is correct. Okay. So first let me know do you understand the why and how this uh, so do you understand the how and why this quotient topology, the quotient space possibly will be same as our usual topology? Okay. Please let me know till now do you understand everything or not. So this is first step. Okay. Now secondly you need to prove. Yeah, do you have any question?
No, no, I understand. That's
Okay. Okay, thank you. Okay, so this is the first step, which is over already. Now, for the second step, you need to prove mathematically. To prove mathematically, x lower distant equal to real life. Now, you try to prove this. X lower distant is proof. Take your time, think about it. Please let me know the answer. Or at least tell me how you approach this problem. Okay? Please take your time and try it. I shall be after a few minutes. Okay. So, anybody have any idea or any guess how to approach this problem? Or can anybody please suggest some way out to solve this? Or at least in order to apply the X upper strategy we want to R, what we need to show. So what is needed to be shown fundamentally in order to prove that X upper is equal to R? That is equivalent how to use universal property. Can anyone please speak up? Uh, please don't be silent because these sessions are basically problem solving sessions. Whatever is coming in your mind right now, you can speak it up without any hesitation. Okay. So does anybody have an idea? Or at least can you please tell me how to start this problem? Can anybody please tell me how to start this problem? Okay. So um, okay, so uh, what? Okay. So uh, let me explain how to use the universal property. Okay. So basically, you need to do what? We need to find what? We need to find a map. How? What map? A continuous map. But not just continuous map is important. We need to find a quotient map. Okay. We need to find a quotient map. Find a quotient from from where to where? From X to that real line, such that not just random quotient map. That quotient map should have some property such that if X equal to f of y, if and only if X is related to y, that is an algebra, which is, I mean, so how you can remember this formula? In algebra, you have done that first isomorphism theorem, right? So suppose there is there is some group G1 to G2 and what? And suppose F and suppose it is surjective plus which is surjective. Then we know what G1 by kernel of F is isomorphic to G2. This is same as saying that kernel of F is nothing but Fx equal to. So this same as saying that the relation is that X related to Y if and only if their difference belongs to kernel of F. Exactly here the same thing. That is Fx equal if and only if X is related to Y. In the group theory we have done Fx equal if and only if uh, if x minus y belongs to the kernel. So in this way, you can remember this theorem. Okay. So basically, what we need to find a quotient of little f from x of x to r such that if of x equal to f of y, if and only if x equal to y. Okay. And yeah, so that's what you need to figure out which function will do the job. Along with the fact, you need to keep in mind that the function should be continuous. Okay. So yeah, so this is what we need to do. I mean, so what we need. So this is what we need to find actually. Okay. So till now, do you have any question or any doubt? Please let me know. So this is basically nothing but the application of the universal property. So in order to apply the universal property, let me repeat. In order to apply the universal property, what we need to do? We need to find a quotient map, little f, what to add from x to r, having a property such that two points are equal under f if and all if they're related. Okay. So this is what we need to find. Now try to find such a function which satisfies that property. And of course, you need to look into the given equivalence relation in order to find such a function. So think about it and please let me know. Now this should be very easy. Please think about, take your time and let me know. Until now, if you have any question or doubt, please unmute yourself and ask.
Can you repeat once from the beginning of this answer? What is the step-by-step process we will?
Yeah, sure, sure. What? Yeah. So let me, okay, so I understand this question is quite difficult. So let me start from the starting. Okay. So So the question is that given x equal to R2, when it is R2 means it is R2 with the usual topology. Okay. Now over R2 there is an equivalence relation. What is the relation? Two points are related if and only they lies on the same parabola. Okay. Now the question is if we quotient the R2 with that equivalence relation, then there will be some quotient space denoted by x upper star. Now question is the x upper star is homeomorphic to something. We need to find it. We are trying to find out what is the space. Okay. So this is the question. So first, okay, so in topology, you need to understand the very basic fact that in order to prove something, first you need to guess this will be the case. Otherwise, you cannot prove anything in topology. Okay, so that's the problem of the subject. I mean, okay, so that's the thing. So first, let me explain how one can guess the corresponding quotient space because that is a very crucial step for this whole argument. Even in exam also, you need to first guess. Otherwise, you cannot prove anything. Okay. So the question is given in such a way that so this tells that two points if 2 points lie in the same parabola, then all those points are equivalent. Okay. So this tells what? If we consider this intersection of this parabola with the x-axis, those points equivalence class contains all other points of the respective parabolas. This means what? If we consider those 2 points on the x-axis, we will eventually get whole x upper distance, the quotient space. Okay. So this tells that the whole that each so this tells that a whole x-axis that the real line is nothing but the quotient space. So this is my claim. Okay. This is the case. So now we are trying to prove that that x upper star is equal to real line. That is, we need to show that there exists that is x upper star is homeomorphic to the real line with the usual topology. This is what we are now going to show. So now for the second step, we need to prove it mathematically. Okay. Now to prove something mathematically in the quotient space things, we need to use a universal property. Okay. If you don't can't remember the universal property, that's okay. Universal property, I mean, okay. So let me explain how you can apply the universal property. That is most crucial. Okay. So in order to apply universal property, what we need to keep in mind? You need to keep in mind that you need to find out 1 minute. 1 minute. Yeah. You need to find out some quotient map. Little a from what to what? From x to r, such that fx equal to f of y if and only if x is equivalent to y. Okay. So this such a quotient map we need to figure out. Okay. Now, okay. So now this is the this is the last part. So you need to find such a function satisfying such property, having such property. Okay. Now please think about it. Take your time. Please look into the question itself. There is a high possibility that you can catch the function itself. Okay. And after observing that the function will be like this, you need to also prove that the function is a quotient map. Okay, but showing something quotient map is a somewhat a different story. First tell me what will be the function. First find out the function itself. Okay. Please take your time, think about it, let me know. So till now everything is understood properly? Please let me know.
Yes, yes.
Okay,
And
thank you.
it seems to me that question map will be xy going to x minus y square or x plus y square.
Yeah, that's very good. Okay. So as per you have told, so I'm not waiting. So, so, so the question map will be f of x or y will be x plus y square. Okay. So, as per Shume's told, this is the question map. I mean, this is our candidate. Okay. Now the last part remains. Prove it is a question map. Show that it is a question. Please think about it and let me know. This proving this is a question map is not straightforward. Take your time and let me know. Please think about it. I shall be back in a few minutes. Okay. So are you able to figure out what will be the question map? Sorry, I mean, how are you able to figure out that how to show this given map as a question map? Of course, the definition will not be helpful. So you need to use some trick as you have already noticed. So what will be the process of showing such a map for the question?
So it will be continuous because it is polynomial into variable and it is surjective,
Okay, then
and other is the inverse image of open set is open in the cosine space. And
I mean
that
that's
is right hand side.
um, so that is one direction. Another direction is if U that is in the domain side, any open set is there. Sorry, I mean the point is that if U is an open set of real line, and if F inverse U is open, then also you need to show U is open. How to show that? So you told that U open implies F inverse U open. That is fine. But now the reverse. F inverse U open implies U is open. How to show that?
But that is the definition of cosine topology in the cosine space, right?
Yes, correct. But that's what we need to show that if inverse U open implies U is open. Otherwise, we cannot say that given map is a question map, right? See, in order to show some map is question map, we need to figure out three things. First is issue subjective, that is there. Second is that U subset of real lines, subset of codomain is open if and only if F inverse of U is open. So you told already one side due to continuity, but what about the converse side? Do you understand my point?
Hmm.
Yeah. So
Map is F is defined map from what to what? G mod the
no, no,
cosine
no, 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 not no, no, that
equivalence classes.
no, no, not x to x. So see, if it's from x to r only, we are going to show
Uh,
this map as a question map and this satisfies this property. Okay, then we are done. Correct. So
so
right
that will
now,
satisfy. That is by definition.
that is so this property is getting satisfied, and we need to show it's just continuous surjective and u open if and only if f inverse u open. Okay. So continuous surjective you already told. Now we need to show u open if and only if f inverse u is open, right? Now, U open implies F inverse U open. This is because continuity. And also we need to show converse. F inverse U open implies U open. That is to show F inverse U open implies U open. So this is what need to be shown now. So how to do that? Advance.
Yeah.
Yeah. Please think about it and let me know. Please take your time.
Okay. So here it is injective and um,
No, no,
subjective
no.
as well.
Uh, no, no, it is just it is not subjective, right? Of course, because I mean, if you consider this relation, sorry, if you consider this relation, it is of course not subjective, correct?
No, it is injective.
So yes, it is no, no, it is not injective even. This relation tells that
Oh,
there are
sorry, sorry. Yeah. Hmm.
so that's injective. So think about it. Take your time. No, there is no hurry. Take your time. Think about it. How to figure out. Of course, there is a trick involved. Try to figure out that trick by yourself first. Else, I will discuss. Okay, please take your time. In the meantime, let me find out some other questions also.
Okay. F will be cosine map if it satisfies the condition f x equals to fy, if and only x equivalent to y, right? That is the condition.
Yeah, that is one condition which is getting satisfied, right? By our
Yes.
choice, by your choice. So everything is figured out, but only one thing remains, namely the following. Let me write it down. That is, if inverse u, if inverse u open implies u open. This is to be shown now. This is the only thing remains we need to prove. Correct? Are you understand my point?
F is different from the quotient space to R,
No,
right?
no, no, no. F is defined from X to R. X is the original given space.
Okay, okay.
So now try to figure out how are you understand my point, or
But
should I
but I
explain?
think but I think you have to quotient it with the kernel of this F. Then we'll
Yeah, you're absolutely correct. That's it. So that's why the universal property comes to the picture. Okay, so let me go up slightly. So yeah. So what we are trying, to find out the quotient map little f from x to r such that fx equal to fy if and only if x equivalent to y. This is similar to saying that there exists some f tilde from the quotient space to R, which will be homeomorphism. Correct. That means to say, so there such a diagram will be there. Correct.
yes.
So we are not trying to figuring out this f tilde. This f tilde comes automatically from the little f. Okay, and why this so? This is due to the universal property. Okay, that's why we are trying to figure out the universal. We are trying to use the universal property. We can directly show that x upper star will be equivalent to real line with usual topology, but that will be hard, extremely complicated. Okay, because the open sets are closed states will not be natural there. So that's why we are going to get universal property in order to show that quotient space will be the real line. Okay, and what is the process? The universal property tells that we need to find what? We need to find the quotient map where from x to r. We satisfy the following property: fx equal to fy if and only if x equivalent to y. If we can construct such a function at least one, then we can say that x operator will be homeomorphic to little r. Okay, that's why we're trying to concentrate to find out that if along we need to make sure that those properties are getting satisfied. Do you understand my point?
Yeah. So now
Yeah.
what is remains to do?
So okay, okay. So there are a few things we need to check. So we need to check this fx equal to fy if and only if x equivalent to y. This is getting satisfied or not, which is obviously getting satisfied. Okay, so let me write it down one by one. I think it's become quite cumbersome. So let me write it down. So let me write it down, which is getting automatically satisfied. So fx equal to fy if and only if x equivalent to y. So this thing is getting satisfied automatically. Okay. Second point is what? Second point is f subjective. Okay. This is also getting satisfied. Okay. Third point is f continuous. That is also getting satisfied. Fourth point is what you need to check, that let u subset of R with if if inverse u open in X. Now we need to show u open in R. So this is the precise the converse of the continuity, right? Now this is what we need to check, and this is the last thing we need to check for to solve this question. Do you understand my point? Are you getting it properly?
Yes.
Yeah. So please now, so now it is
So
clear how.
better to show that F is open map actually.
Okay, to whatever. Okay, so yeah, so that's what I'm saying. Please think about it and please think first. Okay, and if you say that if it's open, then also you need to show that it is open. You need to prove that it's open. Okay, but I don't think for this map x plus y square it is an open map. I don't think so. Okay, first you think about it. Okay, and let me know. are you understand properly what we need to show? I understand it's quite tricky, but in case if you did not understand till now, what we actually need to show, what is the rest we are trying to show? Please unmute
Yeah,
your.
you were saying that you need to show that if inverse U is open, then you have to show that U is open.
Yeah, correct. Right. Perfect. So now try to figure this out how to approach this. Okay? Okay. Take your time. Okay. So are you able to figure out how to show the statement or any idea?
No, please elaborate it.
Okay. So for this we are going to use one fact. Okay. And we shall prove the fact later on. I mean, we have discussed the fact, but let me write it down here. So let f x to y be a continuous, of course, in topology maps continuous, and p y to x be another continuous map such that if composite p is identity map of y, okay, then f is a quotient. So this is the fact that we have used, we have proved in the last session. This is the fact we are going to use. So that is, we need to show that, sorry, it should be P composite F. Okay. So now we need to find such a P, correct? Now, for this our purpose, to find P from R to Y with X goes to X comma. Okay. Sorry, this should be F. Now, so this tells that now if we consider f composite p of x, this will be what? F of x comma 0, and this will be x plus 0 square, that will be x only. So this tells that f composite p is equal to identity of what? R. So this tells that f is a quotient. So yeah, so this is the trick. Are you following, or are you understanding?
Yes, thank
Yeah.
you.
Okay. So okay, so this question is clear to everybody, I hope. Okay, so now let's move for the next question. Hmm. The next question is the same, but almost same, not just same. Okay. So the next question is for x equal to R2, and here we are defining the equivalence relation x1 y1 related to x2 y2 if and all if x1 is square plus y1 is square is equal to x2 square plus y2 square. Okay. Now, of course, find the quotient space x upper star. Okay, that is, you need to show that x upper star is similar to some space, some familiar space, and you need to find what is that. Okay? So it is exactly same as the previous one. Please think about it. Okay? At first, try to guess. First, try to guess what will be the x upper star possibly. Okay. First guess. First guess x upper star. What it will be. Okay. Please think about it and let me know. Okay. So are you able to figure out what will be the possible quotient space? I mean, are you able to guess till now? Okay. So let me explain it. One, two, one. Yeah, okay. Okay. So let me explain it. So, so look. Uh, okay. So this is real. Okay. Sorry, this is R. Okay. What happened? Okay, this is R. And in R2, consider concentric circles. The center at origin. Okay. Now all these concentric circles, all of the points, all the point. I mean, so in each concentric circles, all points are given. Okay. So if we consider the positive set intersection of the concentric circle with the x-axis, consider all possible such points. Dot dot dot. All these points represent the all possible concentric circles in the question space. Correct. So this tells that what? And if since we are considering the positive intersection of the circles with the x-axis, so this tells that x upper star, the high chance it will be equal to closed zero, open infinity, because closed zero is a point also. Okay, we cannot ignore that. Closed zero, open infinity. Okay, there's a high chance it might be the possible. It may be the possibility. Now you need to prove that this is the case indeed. Okay, so yeah, so try to figure this out or try to show. Now show that closed zero open infinity is homeomorphic to what? Homeomorphic to x upper star and use universal property. Okay, please think about it and let me know how you can show that this is homeomorphic. So of course you need to find a universal property, but for universal property we need to use so we need to construct some function f from x from what from some suitable spaces and figure it out and let it. Okay, so are you able to figure out what will be the corresponding reversal maps? Sorry, I mean, yeah. So we are sorry. I mean, for in order to use the inverse product, we need to figure out what question map we should choose. So are you able to figure out? Yeah. So choose f from where to where. Fx to 0 infinite obviously. X to y goes to x square plus y square. Now we need to show three things. Show that f is quotient map. Secondly, fx equal to f of y if and only if x equal to y. Okay, so these two properties we need to ensure. Okay, so in order to show if it's quotient map, what we need to show? We need to show that if it's continuous. Let me write it down clearly. We need to show what? If continuous, if surjective, and thirdly, U subset of R, so 0 infinity, with if inverse U open. This implies these three things have to figure out along with this property. Now, try to find out which one it is. Of course, everyone is getting satisfied, but you need to figure it. You need to verify yourself first that all are getting satisfied. Okay. So yeah. So now this is the main remaining task for this question. So please take your time and let me দুটো কোশ্চেন একটু So okay, this is quite tricky. So can anybody please speak up? That which property of F is getting satisfied as per your point of view? Can anybody please skip up? Skip up. Which points of F is getting satisfied from your point of view? Okay. So let me write it down. Okay. So first of all, observe that if is continuous, this is very much clear. If is surjective, this is very much clear. If x equal to f or if and only x equal to, this is very much clear. Only to show that u subset of 0, infinity with f inverse open implies u is open. This is what is need to be shown separately. Okay. So so how to do? So the treat will be as follows for previous. We need to constant the function. Okay. So the function is p from where to where? From 0 infinity to x. Okay. The function with x goes to root over x. Okay. Which quite makes sense. And then f composite p of x is equal to f of root over x comma 0, which is nothing but root x square plus 0 square, which is x. So this says that p composite x is equal to identity of 0 comma infinity. So this tells that what? This tells that f is a quotient. I don't understand. So I don't understand. So basically, what we're doing, we basically construct this function p from 0 infinity to x such that if composite p is identity on what? On the Corbin side. This tells if it's a quotient. Okay. And this tells that this property is getting satisfied. So yeah, so that is the process. Is it clear to everybody? Please let me know. Is it clear to everybody? Okay, I have so okay, thank you for confirming. So now Okay. So now let's go for the next question. 1 minute. I need to check once. Okay. The next question is as follows. Sorry. Okay. So next question is, show that the projection pi from x plus y to x is a quotient. You need to show the projection of the quotient. Okay. So yeah. So So please try to do it by yourself. There is nothing to explain much. Please try to figure out by yourself. Okay. So, oh, so look, anybody able to solve it? Okay. So it seems not. So let me explain. Okay. So first observations are the following. Projection of pivots is continuous. Surjective. Okay. Now, if pi 1 open, then that will tell that, then we can say pi 1 is question, right? Why? Since why? Since open map is a question. Pi 1 is continuous surjective. So if pi 1 is open map, then we can say that pi 1 is question. Okay. So now this boils down to showing. Now, so the whole thing boils down to show that pi 1 is an open. So now try to show pi 1 is an open map. That is what it is to show. That is to show pi 1 of u is open in X whenever u is open in X cross Y. This is what is need. This is what is need to be shown. Correct. So yeah. So that is the thing. So yeah. So think about it and let me know. So you need to show pi 1 sends open set to open set. So now think about it and let me know how to approach. I mean, the point is it is not too difficult, it's not too easy, but think about it. Now, what do you need to show? You need to show if you consider open map, open set in X plus 1, that is similar to showing that pi sends an open basis, pi sends a basis element to an open set. That is what it is, right? That is, or equivalently, pi 1 of basis of X cross Y is open in X. So this is actually is near to be shown. Now think about it and let me know. Okay, take your time. So are you able to figure out how to show that um, pi 1 of base element will be open in X? Sorry. Okay, so let me explain it. So so basically, if you believe it, so any basis element, how it looks like? One. How it looks like union of alpha going to this u alpha cross v alpha, right? Now we are having a pi 1 of union of alpha u alpha cross v alpha, where u alpha and v alpha open and equal respectively. This is equal to union of alpha pi 1 of u alpha cross v alpha. This is equal to union of alpha u alpha. And this whole thing is open in where x. Correct. Since each u alpha is open in x, okay? Yeah, yeah, so this is the argument. Are you understand? So what we have done? We showed that pi 1 of union of that t is equal to union alpha u alpha, that is open in x, and so each is open in. So that is what we are trying to show. Understand? So yeah, so that's all. So let me. So this tells that. So this tells what? Okay, so let me finish it. This tells that pi 1 is an open, and so this implies pi 1 is a quotient. So yeah, so that is the whole argument. So is there any kind of doubt? If yes, please let me know. Okay, since you don't have any questions, so let's go for the next question. Okay, the question is, so the next question is, now let's start some question compactness. Okay, let x be a sequence such that x goes to x. So X in a sequence that converges to some point X. Okay. Show that show that a set Xn units X is common. Okay. So okay. So X is a sequence. So I mean, so you may consider X is sequence in what? In some topologicals, what I must mention is that. Now such that Xn goes to X. Okay, now we need to show that the sequence Xn along with the point of convergence, all this whole the together set is compact. Okay. Please take your time, think about it. That is what it is. So you need to show that is to show every open cover as finite. Every open cover has a finite subcode. Okay, this is what is need to be shown. Okay, think about it. Let me know. Please take your time. Okay, so anybody will to figure out? So yeah, so there is nothing to figure it out actually into Pro, but anybody can immediately speak up how to uh, proceed. Anybody, please? Okay, so it seems that it's quite complicated. So let me explain this. Okay, or let me write a solution. Okay. So in the meantime, if you get any doubt on it, please let me know. Okay, please do not hesitate. George. Okay. So so you need to show something is compact. So what you need to show? Any open cover is a finite cover. Okay. So let U alpha be an open cover for X. So this is an open cover for Xn unions. Okay. So so let X belongs to U alpha. Okay. So this implies what? This implies there exists an um, okay. There exists n such that Xn belongs to U alpha naught for all n greater than equal to k. Sorry, it should be there exist k. Okay. Now x1 this may belongs to U alpha 1. X2 this may belongs to U alpha 2. Correct. Xn belongs to U alpha. Okay. So this tells that what? The sequence Xn union X. This lies entirely into U alpha naught, U alpha 1, dot dot dot, U alpha k minus 1. Okay. So this tells what? This tells that this open cover U alpha has finite sum. So yeah, so this is the whole argument. How do you understand? So suppose xn is a sequence such that xn go converts. So let me repeat it now from the starting itself. We need to show that xn, the sequencer itself with the pointer convert is a compact. Okay. For that, we start with some open cover. We start with the open cover for xn, and we choose this open cover. Oh, sorry. It open cover must have a finite sum. Okay. So for that, what we're doing, there exists k belongs to n such that xn belongs to u alpha naught due to converts. Why? By convergence. Okay. Now, x1 belongs to u alpha 1, x2 belongs to u alpha 2, that xn belongs to u alpha n. Okay. So this implies that the sequence set xn along together with the point of convergence lies inside u alpha naught union u alpha 1 union u alpha k minus 1. So this tells that sequence u alpha has finite subcover, namely u alpha naught, u alpha 1, u alpha. Okay. So this is the argument. Is it clear to everybody? Please let me know. Okay. So I have this clear now. So let's move for the next question. Tells that. Okay. So this question is quite interesting. So it's quite tricky also. Let XD let XD be a metric space. Okay. And let A comma B be disjoint non-empty closed subsets of X such that for every X belongs to A and Y belongs to B, we have T of XY. This is greater than R. Sorry, it's my mistake. So space and let A and B be disjoint closed subsets of X such that B X such that they compact. No. So the B compact, so the B is compact. Show that the index are greater than 0 such that Pxy is greater than R for all X belongs to A and for all Y belongs to B. So this is what. So let me explain the example. So there is a metric space, and there are some closed disjoint subsets of X, closed disjoint B compact. So that there is R greater than 0 such that this whole. Okay. So you can proceed. You can either prove it directly, or you can proceed with the method of contradiction. Okay. Okay. So hint is proceed with the method of contradiction. Hint is use contradiction. Now think and tell me what will be the if we assume contradiction, the finally what we will get. Okay, think about it. Let me know. So okay. So suppose it is contradiction. That is what? That is for all r greater than 0, there exists x, r, and y r such that b of x r comma y r less than equal to r if x r belongs to a, y r belongs to b. Now we can take n. That is, so we get a sequence xn in a and yn in b. So the dxn comma yn less than equal to n. Okay. Now B is compact. B compact. So this implies Yn as convergent subsequence. Call it Ynk and let this Ynk goes to Y, which also belongs to B. So this tells that okay. Okay. Sorry, it should be 1 by. This tells that xn also going to Y. Correct. So this implies that A intersection B non-empty. So this is the contradiction. Why? So basically, I have done nothing but use the method of contradiction in order to show the intersection of A and B is not. Okay. Please think about it and let me know in the next session. And if you have any doubt or any question, please let me know in the next session. Okay. So I am leaving. So let's stop here for today. We shall meet on the next Friday. Okay. Thank you for attending the session. I'm leaving the call.